Hello everyone, welcome to 9231 Further Mathematics. I'm Anvay and I'll be teaching uh, all four of the main parts. We'll start off with part 1, which is Further Pure Mathematics 1. The first topic here is roots of polynomial equations. Uh, and we're going to be talking about two specific things within that. So the first and the second bullet point. We'll cover the first bullet point in this video and the second one in the subsequent video. So let's just dig into it. Recall and use the relations between the roots and coefficients of polynomial equations. And the example they've given is to evaluate symmetric functions of the roots or to solve problems involving unknown coefficients in equations, restricted to equations of degree 2, 3, or 4 only. So what this basically means is, the left part, recall and use relations between the roots and coefficients of polynomial equations. So the word polynomial itself defines algebraic expressions made up of one or more variables and a sum of terms involving non-negative integer powers of variables. So for example, this is a polynomial. This checks out. However, when we have something like let's just say 3x to the 1 by 2, this is not polynomial, or 3x to the 1 by 2 plus x, this is still not a polynomial because the powers are not integral. Neither is like 5 by y or times x or something. That's not a polynomial either. So that's a polynomial, just for clarification, if you guys were wondering. But yeah, now I'll go on to like the main stuff. So we'll look at quadratics, cubics, and quartics, and then we'll go into the general relationship of roots and coefficients in polynomials. So what I mean by this is, let's say we have a quadratic, so we have ax squared plus bx plus c, right? This would have roots alpha and beta. Let's define roots as alpha and beta. So then we have, let's just write this as f of x equals. So then we'd have f of x, right, equals, well, a, because that's our coefficient outside, times x minus alpha times x minus beta, where alpha and beta are our roots, right? The thing is, when we simply expand it, we just get f of x equals a times, and then expand this. So this times this, so x squared minus alpha x minus beta x, so minus alpha x minus beta x, and then the last one is just plus alpha beta, right? And everything is multiplied outside with a, right? This is also equal to ax squared plus bx plus c, equating the coefficients. Coefficient of x squared is just the same here, so ax squared, cool. Now the b value here, so b from this equation tells us that b equals, well, we have this part over here, and we have a on the outside that we're multiplying with it. So b equals a times, and then negative alpha minus beta, right? Another way to say this is, this implies that, well, just take the negative of both sides. So we get alpha plus beta, right? And then divide both sides by a right here. So we get negative b because we multiplied by the negative, and we divided by the a, so negative b by a. So basically we say that the sum, using the sigma notation, you've probably seen before, of alpha is equal to negative b by a. And this is actually the general formula that applies to all polynomials, where a polynomial is defined by f of x equals ax to the n plus bx to the n minus 1 plus blah 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 plus some a n a1 x to the power of 1 plus a0 or something like that. Ideally, we would actually call this part here a n minus 1 and this a n, but pretty much just remember that the coefficient of x to the n minus 1, where n is the degree of the polynomial, uh, can be used in this formula to find the sum of roots. Going on to the product of roots, actually, I'll just erase this really quick. But pretty much the product of the roots can also be found. If you want to pause the video and try to find how we could do that, go ahead. But pretty much here it is. So we have the third coefficient that we equate to this. So we just say C, C equals A times, and then we have alpha beta on the inside. Okay, this implies that alpha beta equals C by A. Notice how the negative sign here is missing, because basically it's sort of alternating, you could think about it. So when we have alpha beta, it's positive, right? C by A. If we have alpha beta gamma, if there were a third root, which we'll get into for cubics, then it would be negative, and then you could see the pattern. It's negative D by A, right? So pretty much we denote this as just sum of alpha beta equals C by A. Okay? If I actually only keep the important bits right here, 1 second. If I only keep these two main formulas that we need, and erase the rest of the stuff, because that's just proof, that could be done easily. And we focus on cubics now. We could think of a third root, gamma. Oops, I'll just write over that again. But pretty much we could think of a alpha beta. Yeah, so we could think of a third root gamma, such that f of x equals a times x minus alpha x minus beta times x minus gamma, which is equal to ax cubed plus bx squared plus cx plus d. Okay, here we equate the coefficients, and I'll just simplify. I'll just fast forward, and we'll basically get to the point where ax cubed is right here, and then we have ax cubed here as well, right? So that's fine. Then we have b, right? How do you find b? So that you find x squared. So this times this times this plus this times this times this again plus this times this times this. So we basically get x squared times ax squared, right? A times alpha plus beta plus gamma negative, the whole thing negative because it's negative here, negative here, right? Equals b, right? And then we get the same formula. We get the bx squared, right? And then the x squared cancels that. And basically we get the same formula, right? The sum of our roots, alpha, beta, and gamma, is just equal to negative b by a, right? As we had right here, right? Pretty much, we repeat the same process for the others. So for c, right here, c, the coefficient of x, we have x times this plus this x times this plus this x times this, right? So we basically get all the possible combinations of the roots, right? So we get alpha beta plus, because we're multiplying negative by positive, so we get negative positive at the end, right? So alpha beta, not negative alpha beta. Then we have beta gamma, then we have alpha gamma. These are all the possible combinations. Times ax, right? Remember to multiply the a, and then it's the coefficient of x is equal to cx. So this again gives you alpha beta, beta gamma, and alpha gamma, which looks like this formula right here, doesn't it? So we could just state that the sum of alpha beta, where alpha beta is the product of two roots, and the sum is significant of their combinations, and the combinations of their products would be equal to c by a from this equation right here, right? Lastly, we'll be able to see now that there's a pattern going on. So if you can see from this equation right here, we can predict that well, it's negative b by a. This is c by a. So the next one should probably be negative d by a, shouldn't it? Right? So basically, we could actually test that theory right here. So we have d, the constant, right here, and we have alpha, beta, gamma, and a on the outside. So basically, d equals negative a alpha, beta, gamma, right? Because negative times negative times negative is negative, right? So this implies that the product, which we also write as sum of this these three, uh, and sum of these three like multiplied together, which is pretty weird, but for higher powers, this is the general formula, equals negative d by a, as we predicted. So essentially, this is sort of the thing you have to remember. Then for a quartic, where you'd have an extra root that we could denote as, let's say, delta, right? Equal, well, you can guess by now that it's e by a, right? And this is the same. This applies to all powers. Uh, of course, for a quadratic, you can't really have uh, three roots, can you? And then for a quartic, you can't really have uh, five roots, or in cubic, you can't have four roots. But just apply it as it's necessary. And these are the four main things you should be taking away from this video. Uh, in the next video, we'll get more into the sort of problems you'll find regarding this. All right, thanks.